Hello viewers, in the previous video, that is in part 5 of 12b, I have explained up to number 10, and in this video I am going to explain from question number 11 of 12b. Now the question is, the diagram shows a sector of a circle of radius r making an angle theta degree. The area of the sector is a centimeter square and perimeter of the sector is 50 centimeter. That means in this figure, radius is r and this angle is theta. It is mentioned that the area of the sector is a centimeter square and perimeter of the sector is 50 centimeter, and we are to prove that theta equals to 360 by pi into 25 by r minus 1 and area equals to 25 r minus r square. In this question, this part is radius, this part is radius, both are r, this angle is theta, and we are to prove that this theta equal to 360 by pi, 25 by r minus 1, and area of this sector is 25 r minus r square. Okay, now what is the perimeter of this sector? Perimeter of a sector, we know it is r plus this part, because perimeter is nothing but it is the boundary. So perimeter of this sector will be r plus r, that will be twice r plus arc length. This arc length, we know the formula, theta by 360 into 2 pi r. As perimeter of the sector is given 50 equal to twice r plus theta by 360 into 2 pi r. This twice r can be transferred in the other side. So 50 minus twice r equal to theta by 360 into 2 pi r. We are to find the value of theta. So 360 and 2 pi r we will transfer in the other side. So we will get 50 minus twice r into 360 divided by 2 pi r equals to theta. Now as we are to prove 360 by pi outside, then 25 by r minus 1. So 360 by pi I have written outside, and since 360 by pi is outside, we are left with 50 by twice r minus twice r by twice r equals to theta. Now 360 by pi, 2 and 50 can be cancelled. We will get 25 by r minus 1, because twice r divided by twice r it will be 1 equals to theta. Therefore theta equals to 360 by pi, 25 by r minus 1, and this is what we are to prove. Now in the second part it is given area of the sector is 25 r minus r square. For this, as given in the question, area of the sector is a. We know area of the sector is pi r square theta by 360 equals to a pi r square 360, and instead of theta we can write 360 by pi, 25 by r minus 1. We have replaced theta with this value equals to a. So this 360 can be cancelled, pi can be cancelled, so we are left with r square, then within bracket 25 by r minus 1. Now if I multiply r square and this, we got r square into 25 by r minus r square into 1 r square equals to a. Clear? So r square and this term is multiplied, r square and 1 is multiplied. R square and r, one of the r can be cancelled, so we are left with 25 r minus r square equals to a, and this is what we are to prove, that area of the sector is 25 r minus r square. I hope this sum is clear. Let me explain the next sum, that is question number 12. Question number 12 is, find the area of the sector of a circle with radius 4 centimeter and of angle 30 degree. Also find the area of the corresponding major sector. So quite simple sum. Here radius is given 4 centimeter, angle is given 30 degree, and we have to find the area of the minor sector and major sector, and where we have to take pi equals to 3.14. In question number 12, theta angle is given as 30 degree and radius of the circle is 4 centimeter. We are to find the area of the minor sector and the major sector. We know the area of the minor sector is pi r square theta by 360. Now pi, as given in the question, 3.14 into r square, radius is 4, so it will be 4 into 4, theta is 30 degree by 360. Now 30 and 360 can be cancelled, and we will get 12. 4 and 12 can be cancelled, then it will be 3. Now 3.14 into 4, it will give 12.56 divided by 3. If 12.56 is divided by 3, we will get 4.186, which on rounding it will become 4.19 because it is 4.186. Since this digit is more than 4, cut and you add 1 here, so it will be 4.19. Therefore, area of the minor sector is 4.19 centimeter square. Now in the question it is given, we have to find the major sector also. And since we got area of this part, so if you want to find the area of the major sector from the area of the circle, we have to subtract this part. So on subtracting area of the minor sector from the circle, area of the major sector can be calculated. So we can write area of major sector is area of the circle minus area of the minor sector. Now area of the circle, we know the formula pi r square, and here radius is 4. So it will be pi 4 square minus area of the minor sector is 4.19. Pi is 3.14 into 4 square 16 equal to 4.19. If I multiply this two, I am going to get 50.24 minus 4.19. On subtracting, it will be 46.05. If I round it, then I am going to get 46.1 centimeter square, and this is the area of the major sector. It's a simple sum because theta is given, radius is given. Directly by placing this formula, we can get the area of the minor sector, and then from the full circle, if I subtract this part, then I am going to get the area of the major sector. I hope this sum is clear, and now let me explain the next sum, that is question number 13. In question number 13, it is given, find the area of the segment AYB. We have to find the area of this segment. If the radius of the circle is 21, so this radius is 21 centimeter, and this angle AOB is 120 degree, and we have to use pi as 22/7. So it's a simple sum because radius is given, angle is given, and we have to find area of this segment. Here radius is 21 centimeter and angle AOB theta is 120 degree. And we know the area of the segment AYB. Area of the segment is pi theta by 360 degree minus sine of theta by 2 cos of theta by 2 into r square. I have explained this formula before. Now we are replacing theta with 120 and r with 21. So 22/7 into 120/360. I have replaced theta with 120 minus sine 120/2 cos 120/2 into r square. R is 21, so it will be 21 square. If I cancel 120 and 360, I am going to get 3. So it will be 22. 3 into 7, 21 minus sine 120/2 is 60 degrees. So it will be sine of 60 degrees cos of 60 degree into 21 square is 441. So next line will be 22/21 minus sine 60, value is √3/2. Cos of 60 is half into 441. Now here 22/21 minus √3/2 into half. Here 2 2s are 4 and here 21. LCM of 21 and 4 will be 84. 84 divided by 21 is 4. 4 into 22, 88 minus 84 divided by 4, it will be 21. So it will be 21√3 into 441. So if I cancel 84 and 441 by 21, it will be 21 here and it will be 4. So we are left with 21/4 and 88 minus 21 √3 centimeter square. As value of √3 is not given in the question, we can keep the answer up to this much. If value of √3 is provided in the question, then only you replace √3 by 1.73 or 1.732. Otherwise, you can keep the answer up to this much. I hope sum is clear. Let me explain the next sum, that is question number 14. In question number 14, the question is, a chord of a circle is of radius 12 centimeter, subtends an angle of 120 degree at the center. Find the area of the corresponding segment of the circle, and in this question we have to use pi as 3.14 and √3 as 1.73. Here radius equal to 12 centimeter and theta equals to 120 degree, and we have to find the area of the segment. That means we have to find the area of this part. We know the area of the segment formula is pi theta by 360 minus sin theta by 2 cos of theta by 2 into r square. Here in the question they have given, we have to take pi as 3.14. So instead of pi, we are writing 3.14 into 120 divided by 360 minus sin 120 by 2 cos of 120 by 2 into 12 square. 3.14 into 120 by 360. If I cancel, I am going to get 3. So here I am going to get 3.14 by 3 minus sin 60 degree cos 60 degree into 144. 3.14 by 3 minus sin 60 value is root 3 by 2. Cos of 60 1 by 2 into 144. Now here 3 and here 2 to the 4. If we take the LCM of 3 and 4, it will be 12. So 12 divided by 3, it will be 4, and 4 into 3.14 is 12.56 minus 12 divided by 4, because here it is 2 to the 4. So 12 divided by 4 is 3, 3 into root 3 into 144. Now 144 and 12 can be cancelled. 12 is 144. Now next step is 12.56 minus 3. Root 3 is 1.73 into 12. 12.56 minus 3 into 1.73. If I multiply, I am going to get 5.19 into 12. Now 12.56 minus 5.19. On subtracting, I am going to get 7.37 into 12. If these two values are multiplied, then I am going to get 88.44 centimeter square, which is the area of this segment. So it's a simple sum. Radius is given, theta is given, just applying the formula. Only thing that you have to do, remember this formula properly, because without knowing this formula, it is not possible to find the area of the segment. I hope this sum is clear, and that's all for today, because question number 15, 16 and 17, these three are not so important for exam purpose. So in the next video, I am going to start from 12C. Till then, bye bye, take care and wait for the next video.